Hello, everybody, and welcome to today's session of 2 Points of View at 2. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we've delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services for companies that are looking to improve their test and quality assurance practices. Before I introduce today's guest, a couple of things. Those of you who are used to seeing me in a suit, you will notice that I am wearing the RBCS t-shirt instead because, hey, it's COVID days. And another thing that I'll mention is that Zoom has gone from being a mediocre product to being an absolutely lousy product in the last few days. According to our guest, he's had some bad experiences with it, with maybe one or two of which he'll share. But we are doing the best we can. Unfortunately, we cannot turn on our camera, so you will not be able to see Rob, which is sad because he's considerably better looking than I am. And also, it will be somewhat disconcerting. So as Rob put it, imagine that this is a call-in radio show. So on that note, I'm happy to welcome and introduce Rob Sabourin to this presentation, where we are going to discuss how to blend exploratory and automated testing to address problems and be effective in your test coverage. So the use of test automation will allow you will free up your manual testers, right? Free them up to do what? Well, exploratory testing, of course. So Rob's going to tell you about that. Rob Sabourin has more than 38 years of management experience leading teams of software development professionals. He is a well-respected member of the software engineering community and has trained, managed, mentored, and coached thousands of top professionals in the field. He frequently speaks at conferences. Remember conferences when we used to get together in person and talk? And he writes on software engineering, SQA, testing, management, and internationalization. He is the author of I Am a Bug, which is the popular software testing children's book that all children of software testers should read. I know mine did. Robert is also an adjunct professor of software engineering at McGill University and the principal consultant, president, and janitor of amibug.com Inc. That's AMIBUG.com. So, Rob, welcome.
Thank you, Rex. Thank you for that lovely introduction. Appreciate it.
Great to have you. I guess I should have had this slide up while I was introducing you, but there's Rob's bio once again. Rob and I have worked together on a whole bunch of training projects over the years. We were co-adjunct professors at University of California, Berkeley for a sort of graduate level, what would you call that? Seminar, symposium?
Well, it was a sort of very specialized training. Yeah, I guess you'd say symposium style, but it was really cool. We had to do some really cool stuff. I have to say, that was one of the coolest training gigs I ever had in my life. We got to deep dive into, I guess it was teaching embedded programmers doing IoT stuff, how to sort of work really effective testing into their workflow and get it done, with lots of exercises and homework assignments and exam questions. And it was just an amazing experience.
It was great stuff. Yeah, for sure. And went surprisingly smoothly, given that the students English was a second language for them. I thought they did very, very well. So
probably the third or fourth language for some of them too. It was pretty impressive.
Could have been, yeah. They were an impressive bunch. So yeah, I agree. That was a lot of fun.
We also did a cool gig over the last couple of years, Rex, when we were probably one of the first projects that got hit by the COVID thing, and we had to change it midstream.
Yeah.
Helping a major American company in their transition to sort of using,
BDD
testing as part of their development process instead of as an after thing.
Yeah.
Pretty cool project.
Yeah, that was a test design using BDD courses. A good course. Hopefully someday COVID days will be over and we'll get to restart that.
Yeah, well, we'll see what happens. Cool. Anyhow, we're here now. So
we're here now. So let's talk. So I kind of queued this up. And so we automate. Everybody loves test automation. Test automation is great. But the thing with test automation is, if you think about software testing, there are two sort of partially overlapping, if you think Venn diagram, aspects of software testing. There's the verification part, which is where we're checking to make sure that the software behaves as we said it was going to behave according to some specification. And then there's the validation part, which is where we're checking to make sure that the software does what people need it to do, right? And those roughly correspond to Crosby's definition of quality on the one hand, right? Conformance to specifications, and Duran's definition of quality on the other hand, fitness for use, right?
Exactly.
So automation can do all sorts of good stuff for us from a verification point of view, because if you think of the automated tests as a form of executable specifications, that you're off to the races. But the validation part is where the humans come in, right? So maybe you could talk a little bit about some of the challenges that that you've encountered when you see people like trying to figure out, well, what do I do with my manual testers now that I've got all these automated tests?
Right. I think that I run into, just as you do, I think what I call a mythology, or what people believe, and it biases how they approach work, which is really interesting. The four myths that related to this subject I see is that, first myth is that all exploratory testing is manual testing. That's a myth. I mean, it certainly is cognitive testing, but use whatever tools you can to get this thing done. If you can write a program to help you explore and learn things, it's great. Some of the best validation work I've done in my career involved using a lot of automation tools to help do it. And it's not that the tool was telling me what is correct from a domain perspective, but the tool was just enabling me to observe and see things and bring things to light. And then if I'm capturing expertise, like I did this in the fashion industry and in the medical industry, where I had crazy domain expertise that was really, really hard to understand unless you really get the master's degree or a doctorate in that specialty. And yet I needed to be able to check 30, 40,000 different cases. And how do you do that when you need the expert? The expert can't sit there with you for 10 or 30,000 things. So what you do is you figure out and you capture things and figure out ways to sort of guide you and say, okay, well, this one now is suspicious. You don't know if it's true or false, but it's suspicious. And you can bring that one and review it with the expert and then build on and on and on. And so there's a lot of sort of things you can actually do to automate that process without replacing the domain expert. I'm not suggesting here magical AI automation that replaces the need for domain expertise. Far from it, but just pragmatic automation to help you observe and see things, and then treating that like a sort of a tool, like a blade on a Swiss Army knife. And you've heard me use these metaphors before, Rex.
Sure, of course.
You drive in there and you say, hey, now I need to write a script to do this or a script to do that, and you do it. So I think for validation, it's really, for me, it's been critical to be able to have as much leverage as I can. And now the tools are getting better and better and better to do that. However, there's myths, right? Like, for example, this myth about automation, like all automation is regression testing. And and I don't want to be critical of individuals here, but I see so much DevOps, CI, domain stuff that's pushing automation. And they sort of say, yeah, everything has to be automated. Well, maybe in the CI pipeline, continuous integration pipeline, you need to do a lot of automated checking, as you were suggesting when you started. But it doesn't mean that all automation is that type of testing.
Right, of course.
Far from true. And if you take it now and you separate the automation from the regression, you start realizing that, wait a sec, every automated script I make doesn't have to run forever. Maybe it just has to be something that's useful while I'm trying to learn about this particular thing. And so you sort of say, I can use automation to help me do something better without having to have that nightmare of, I got to maintain it for the rest of my life sort of issue. That's true, X. It's like,
oh yeah, no, I know.
And that throws people off. It's like they think, oh no, all automation has to be this perfect thing we're going to run 10,000 times and we have to maintain forever. Well, it might have to run for a few days or a couple of weeks, but not for the rest of your life.
Yep. Yep. Oh, so, yeah, what you said just triggered two thoughts for me here.
My video's back.
Yes. I found the hidden setting, which was, yeah. So there you go. Welcome, Rob, in person.
Hey.
Um,
Awesome. Thank you.
so that triggered two thoughts for me. Not all automation is regression testing, of course. Two examples I can think of, the use of basically endless random input testing, right? Sometimes referred to as dumb monkeys.
Monkeys, dumb monkeys. Yes. Noel Nyman's work.
Huh?
Noel Nyman.
Excuse me?
Noel Nyman, when he wrote the articles about the intelligent monkey, right? The monkey robots. Yep.
Well, and that brings me to the next thing that I thought of as just an example of automation that's not necessarily regression testing. My associates and I helped a client build a tool once that was able to read their machine readable specifications for their data capture appliance. Is a special FDA approved appliance that's used to capture data during drug trials. And so they have to have these very formalized specifications for review by the FDA. Well, it turned out that those were machine readable and machine parsable. So we were able to build a smart monkey that would read those specs and auto-generate tests from the specs to the point of being able to actually verify that the displays on the screens were correct. And it would run, you started and it would just take a random walk through the menu structure, because it was a hierarchical kind of menu, and it would just run indefinitely.
What year was that? Was that recent or was that a few years back?
2005, 2006.
That smells of some cool stuff I've seen over the years.
Model-based testing.
Yeah, and it was Harry Robinson and the NASA people were doing that type of stuff, and that was an inspiration to a lot of people who moved into the world of Gherkin and stuff like that, because they want to say, how can we make the specifications so that it's automatable? That's cool. If you can get parsable stuff and then turn that into to test, that's cool. That's sort of exploratory in nature in some ways, but it's definitely non-regression.
Yeah, the tests are different every time.
Right, absolutely.
Unless you force them to be the same, right? I mean, it used a random number, but it would save the seed at the beginning of each run. So if you wanted to reproduce the exact flow, you could manually give it the seed and it would run through that exact flow again. But
on a related thing, I did a radiology project a little bit, maybe 3-4 years after the one you just described. And this was a problem. They were having really weird bugs and hard to figure out and reproduce in their development environment. And so what I did was I worked with them, and we made an automated harness that became part of their normal day-by-day workflow. It wasn't a regression test. It was sort of to play back log files. And they were using a medical protocol at the time. It was HL7. I don't know if you've heard of it.
Yep.
But they had a HL7 log. And what I did was using Perl scripts. At the time, I was scripting with Perl. My apologies to everyone who doesn't like Perl.
Perl is cool.
Syntactically tricky, not as smooth as Python or Ruby, but in its day, it was a really useful tool. And I have to say that I wrote an awesome script that parsed the log file and replayed it, and it allowed them to actually do all sorts of cool stuff. And then it was an enabling thing, and it enabled people to do, and again, I like to say, learning based on like some sort of goals, and that's exploratory testing as far as I'm concerned. They're basically diving in there and saying, hey, there's a log file, let's try it in this situation, let's try it in that situation, let's try it in a controlled environment. But you're taking the log from an uncontrolled environment, right? From the real world.
Right.
And that's, for me, that's beautiful. It's very similar to what you're talking about, parsing something and generating transactions, which can then let you observe the behavior of the system in a way that's realistic, but in a controlled environment.
Right. Which is sort of a cool way of thinking about it. You talk about the control and the observation, breaking those out separately, right? Because usually when we think of test automation, or I think a lot of people, they don't actually separate those in their mind. So they think of those as like, okay, the tool is going to make this happen and make this happen and make this happen, and then check that this happened. But it's like, well, wait a minute, there's the making things happen, and then there's the evaluating the result. There's the observation piece. And what you're pointing out there is I can use a tool to do control only. I can use a tool to do observation only. I can use a tool to do some of the control and some of the observation, and human's still in the loop.
It's really awesome. I just like last week, Rex, did some work in that area, and it was exploration, and I needed a background process to run to tell me when a certain file was changed.
Right.
And this to me is like a probe, a deep sea probe, right? And it's trivial. It's like 5 lines of Python, but it sits in the background, and the script to run it is really small. It's really teeny, but what it does is it tells me, hey, Rob, this thing happened, and it sends me a message. And just having that is allowing me to observe things. And I tell you, with that sort of thinking, you can observe almost anything, any characteristic you want. You can have a little script running in the background to wait for it to happen, and then tell you, hey, Rob, someone corrupted this record. Hey, Rob, someone logged in. Hey, Rob, you're out of memory. Hey, Rob. And this, for me, is sort of like the beautiful use of automation to help you observe things that otherwise are hard to observe, including acuity, Rex. Like you want to measure things like in milliseconds. You can't do that with a stopwatch. You got to sort of have a tool to help you, and it don't have to be fancy. You don't have to go and spend $10,000 with a vendor to just write a little script. So I love to be able to build little snippets of technology, little snippets of automation that help me, and really, what I say, leverage. It's a lever. It helps me see better. And so that's the observe part. And the other one, the playback, is the control part. That'd be both, right? Control and observe.
Right.
And if you want to influence the team, get your developers for every single story they implement to make sure that whenever they change something in the application, there's an external way to observe and control it, hopefully through an exposed API. But that's me. That's my bias. That's how I like to do it. But any way you want. Just as long as you can control and observe it from outside, then you can automate something related to it in a testing situation.
Yeah, though, of course, if you have a conversation with the security guys about what you just suggested, they're not going to be too keen on. Oh yeah, you put an API in there so you can control the software. So
that's right. That's right.
Got to do something about that.
Sensitive to that, and I don't want to violate any security protocols. And I actually have. In my courses, I have a whole section before I dive in and tell them how to do this. I say, be careful. Don't do this in something that's going to be deployed to a customer. You're putting in a hook that a hacker is going to get at. You want to be able to do this carefully and in a safe way and not frivolously. That said, you can still do it, but you have to do it deliberately. So it's got to be really part of the system's architecture to be able to do it, not just hack code here and there.
Right.
That is tricky to use. But you'll see most architectures today, Rex, are multi-tiered at least, or distributed, or REST API, and therefore implicitly you have built into that architecture some of these APIs that your development team should be able to access as part of the process of development, and they should be hard to access, impossible to access, or even not exposed to the outside world.
Right. Well, I mean, to the most obvious example, the most trivial example is lots of times there's going to be some sort of queryable data store at the bottom of the whole architecture, right? And so, you want to check to make sure that the right things are happening. You run a query against database, or check for entries in the file somewhere, right?
These are, of course, what my probes are doing, right? That's what my probes are doing.
Right.
They're doing that in the background. And the probe is running on the server. Hopefully that's under your control, not under your customer's control. But people have done this in big scale too. I mean, I won't mention company names if you don't mind. I've worked with Facebook, and I've seen some of the stuff they're doing. And they do have these probes running everywhere all the time. And they feed really cool information that most people would have no clue what it's talking about. But it's fed back to like like a control center on the live software. It's just lots and lots of probes. Any one probe you make, it doesn't have to be a massively complex piece of software. It
Right.
could be a really cool thing. And as I try to tell people, learning how to do scripting, I think, is a beautiful skill for people involved in software testing to have.
Yeah.
I encourage that, especially the younger generation, I think, are well suited to it because of their technology focus. But even someone who's been testing for 25 years, I think you can still learn how to learn scripting languages, and that's a good
Of course. Well, and I think you sort of, I mean, to remain relevant these days, it's if you don't have enough technical skills to script, I mean, to me, ideally, you'd be able to at least read the programming languages that are being used on your projects, right? It just really marginalizes you if you can't do that.
So one of the things that I was looking at again, this is like work I've been doing the last few days, Rex, so it's so topical. This is really of concern to people today. It's like really a big concern. And I say, if you don't know a scripting language and they want to know which one should I learn, I say, hey, you're on a team. Which scripting languages does your team use? What are the programmers you're working with day by day use? And start with something like that, and then pair with them a little bit when you're trying to write your scripts. You don't have to spend 8 months writing a design specification for a script, but you do have to know what you're looking for. So there's technical savvy involved just in even specifying what a script does. And
right.
a programmer in an agile team, I think, is an excellent way for someone who wants to learn scripting to go. And picking a language or a technology that already is part of the parlance of the team. For example, if your team is using JavaScript every day, then start with JavaScript. If your team is using Python every day, well, start with Python or whatever. Ruby, start with Ruby. Pick one that's already day by day used by the team so that you can pair with your needs.
Well, Python's a good bet too, because that's just recently became the most prominent programming language, displacing Java a year or two ago. So
it blows my mind, Python, Rex. What you can do with Python is fantastic. And it's not because of the constructs of Python. It's because of the community and the beautiful, beautiful resources now available.
Mm-hmm.
I mean, the universe of big data has got Python tools and resources. The world of AI has Python tools and resources.
Oh, yeah.
The world of visualization has Python tools and resources. Any domain you can think of, there's fantastic resources available, and they're really available and not too terribly tricky to learn. However, there's the risk, right? That's third-party stuff. They change it. You got a regression risk.
That's true. That's true. I was just on a conference call earlier today with somebody, and that's a topic that came up of like, there was a change in terms of the version of Python, and potentially disruptive to them. So
I've seen big problems over the years. I mean, with Perl, if you remember the history of that, Perl was changed all the time, so your script stopped working, and it was awful until a company came along. I remember it was called Active State. I'm pretty sure they're still in business, and they started making supported versions of open source tools and technologies. And I think that with Python, the core Python, I think, is well supported and is robust. But all of the tools and libraries, you've got to be careful if you're choosing to use one to make sure that there's going to be support for it, during the life of your project, and make sure it's got a good history. The user communities do have, open websites and share information. But if you go to the site and you see that every 2 weeks they're changing something and they're adding parameters and changing, that's risky.
It's a red flag, yeah. Yeah, absolutely.
For me, it's cool for the guys who are advancing the technology, saying, "Hey, we're advancing and evolving the technology. It's all cool." But for the one who's trying to develop tests, sometimes it's a bit risky.
Yeah, absolutely. Hey, I want to encourage everybody in the audience. As you think of questions, go ahead and throw them into the Q&A panel, because we're coming up on that time here. We're going to open it up for audience questions. So start to throw them in there.
Just Rex, I just wanted to make sure we don't forget also that the automation fits into other areas, right? Like, for example, I use automation. I'll just give you a list here. I'm not going to dive in. I use automation to design tests, kick-ass design tests. And I've got case studies of that happening at some of the most important places, including Amazon AWS. When they're doing their testing, they have tools to help design tests automatically. It's awesome stuff. I use automation to help assess correctness. I told you the example from the medical and the fashion industries, but there's many, many ways to do it that automation really helps me with, including simple things like, as you probably know what checksumming is, Rex, but
Oh, yeah.
some trivial things like that, automatable, clean, really powerful. And then there's dynamic and static analysis. Today,
Yep.
tools that is critical and beautiful. And that is something you can do in parallel to your other efforts to try to catch risks that maybe are going on you're not aware of.
Yeah.
Probes I mentioned, and don't forget non-functional testing. How do you do really good non-functional testing, including stuff like standard stuff like performance and load testing, but then the world of security testing and also privacy testing, all that stuff. There's so much automation support around those things. So it's not just functionality simulation. It's there's lots of things, lots of risks we can explore.
Right.
And tools enable me to do it.
Yeah, like one of the non-functional test things that I've done before is you create some load generators, and they don't have to be very sophisticated. Just something that puts a fair amount of background load on the host systems, and then have your users run either pre-designed tests or exploratory tests, and or not your users, your testers, right? Run these pre-designed or exploratory tests, and keep their eye out for misbehaviors and bad user experience and so forth. It's just basically driven by the fact that there's too much load.
Exactly, Rex. That's beautiful, and it's exactly what I do. In fact, almost the way you describe it is exactly how I describe it to people. Generate load. It doesn't have to be perfect. It's not this pristine load. It's just good load. And I don't want to start using terminology that's funky, but let's say good enough load for the purposes of keeping the system busy, and then see how does your, like, do you're exploring this feature, that feature, that thing, but while load is going on, and you're going to start seeing realistic behavior of the system. If you're the only guy using it and there's no load, yeah, that's nice. It might behave well. But load, and suddenly you're going to start finding real exposure of cool problems that are there, but they're not going to jump out if you're sort of the only guy logged in. So I love doing that type of stuff.
Yeah, it's great stuff.
Yeah.
Cool. Well,
it's not hard, by the way, to do, Rex.
No, I know. Yeah, I mean,
automation like that with JMeter, and if you know a little Java and JMeter and maybe a little Selenium,
yep,
you can whip that off.
Oh, yeah, absolutely. I mean, I've written those kinds of background load generators. I basically would have, one for CPU and one for disk, and one for memory and one for network bandwidth and so forth. And then usually try to have some dials on them that allow me to kind of put some sleep periods in there to kind of reduce the load, or take the sleep periods out to increase the load. And I mean, you're talking about, I don't know, maybe 500 lines of code total across all your load generators. Simple
something
stuff.
That's really cool. It's beautiful stuff. And I mean, frankly, I don't want to put down vendors here. It's the last thing I want to do, but I've seen a lot of people spend hundreds of thousands of dollars on tools, and you start thinking what you just described, which you can whip off in a couple of days with open source tools and well-known technologies. You're doing exactly what they need without the hundreds of thousands of dollars.
Right. No ongoing maintenance costs.
Well, you got to consider things. It is important to be able to repeat these tests, and if you're in a regulated environment, you have to actually be careful about evidence of what you did. So
that's true.
There's reasons I do, like I said, I don't want to diss vendors here. There's reasons for having commercial tools that have sort of good log files and trend analysis and stuff like that, which you don't get from the open source tools. So there's a reason for it. But if you just want to sort of realistically expose good bugs as you're working and day by day work in sprint, by the way, not like 10 weeks after the sprint, that's the way to go, Rex. And that's really being able to use automation to help with some really, really tricky non-functional stuff. And I would argue also security testing too. Load the system like that, like you described, and then do your security test. Take all the James Whittaker security attacks and try them, but as you vary the load. And that's really cool.
Right. Yeah, good points. So let's see, I think we were originally scheduled for 30 minutes, and we got started a little bit late.
Well, we started a little bit funky too.
Yeah, started late and started funky, but I do want to kind of start to wind it up.
Thank you.
So Any sort of final thoughts on that last bullet point there about how automation can facilitate and improve the efficiency of our exploratory testing that we haven't
Yes,
talked about
I
already?
have one comment I'm going to make here, and I don't want to open up a 10-hour discussion of it, but I think that what I encourage people to do is while they're doing exploratory testing, especially reconnaissance, which is learning things that you don't know about that may not be necessarily well documented, right?
Mhm.
But you have to learn about it. Create nuggets of scripts as you go. Create little nuggets, and I'm inspired by Weinberg's Fieldstone book, the Fieldstone approach to writing. Jerry Weinberg wrote a book on that, and what it was suggesting is that collect fieldstones. Fieldstones are what people like in Quebec, where I live, they basically, farmers have them in their fields. They collect them and then they build beautiful houses out of them, like beautiful houses out of fieldstones. But the fieldstones are, you select them as you go for a purpose. Like that's going to be a good stone for this wall. That's going to be a good stone for the fireplace. That's going to be a good stone for the chimney. And so while you're doing your exploratory testing, write little scripts. And it's not creating a library of scripts. It's creating a collection of exemplars that are going to facilitate you as you go in your testing. So I think that's one technique in automation, and using a scripting language mostly. And any of the types of tests we talked about, collect the fieldstones and build. You can build from that then beautiful automation as you go. And you'll also know how to programmatically control and observe the parts of the application in question. So that's a little nugget I want people to take away. Build fieldstones. The tools, whatever tools you're comfortable with, right? It could be fancy tools that know a lot about the technology, like a REST API management software, or it could be just a generic programming language like Java. But build little nuggets as you explore to control and observe parts of the system. And that will be, I think, an amazing resource for you.
Cool. Well, that's a good closing thought. Apparently, we have been so engrossing to our audience that nobody can think of any questions because we've answered all of them or something along those lines. So I will go ahead and wind it up then. So Rob, thanks for your time and for your patience with the
well, thanks for
technology.
inviting me, Rex. And this is a topic that's close to my heart. So if you ever want to talk about this again, it's awesome. And if the community has questions, you'll, I guess they'll get in touch with through you. I'm delighted to follow up offline afterwards. And I have examples of the type of stuff I'm talking about that I share with usually my students, that if anyone wants to see examples of the fieldstones or scripts I'm talking about, I share them with my students. Anyone can contact you and I'll be happy to share.
Well, turns out we do have one late breaking question. So you got a minute?
I'm here for you.
Okay, so we'll take this one and then we'll close it out. So we've got a question from Brian who says, we are using Eggplant to generate automated tests. I'm finding it difficult to share scripts among the test engineers, even though our system environments are supposed to be the same. Something is different, so the other engineers' tests fail to run. Any thoughts on how to combat this problem? Sounds like a configuration management issue to me.
I have a lot of thoughts about that. It's interesting. So you're generating tests in one environment and trying to run them in someone else's environment. And there's something that's different. So this is a problem that's been faced by software testing and software engineers that I was first exposed to probably 1979 to 1982 era, when I really had to hit my head against the wall. And I still hit my head against the wall with it over and over and over again. There's two elements to this. First of all, is your programming style, where you basically have issues there's a dependency there somewhere that's different. Maybe it's the name of an object, or maybe it's something else. So if it's important for you to be able to run this from any machine, then you got to think of it from a point of view of your architecture, and that's what I've learned, and sort of say, okay, well, maybe to get rid of this problem or to turn it to control, I got to break it into what is the dependency and what is not dependent on the environment, and separate them. Best resources on that that I know of is the work of Alan Richardson, who's written several books on the topic, and I don't have his URL by heart, but there's people who show you how to design your scripts so that you separate the dependencies from the logic. So notice, what is the test logic versus what is the environmental dependencies? And so decoupling them is one way to minimize this problem, not to avoid it, but think of this as a blessing. When you have this problem, every time you have this problem, if you can think of the exploratory testing mindset, if I can give you to, learn from it and say, okay, I gave it to this tester, he can't run it. Why? Learn why. And then that's an environmental dependency, and decouple it. And so the next time you're always going to have that sort of decoupled. And there's, believe me, I've done this compatibility problem for years and years and years. It's not going to go away. And if you try to write something that is general purpose that writes on any platform in the world, you're never going to get the job done. So you have to learn and learn and learn. And if there's 10 factors in your organization that matter, maybe it's the network protocol, maybe it's the type of operating system, maybe it's the version of some tool, but that becomes a dependency, and you learn from every single time it fails. And then you'll be able to evolve this. And it doesn't take 60 iterations. It takes a few to get good. But you can also follow the school of thought where you have to architect everything. And Dorothy Graham's book on patterns for test automation, which was published about 2 years ago, Rex, I don't know if you're familiar with it.
Yep.
She's got in there over 100 different patterns, which are almost all designed to try to avoid that problem. But that's more leaning towards regression type of stuff, right? So there's a difference between a test that you want to maintain and run forever, or a test that you want to use for the job at hand.
Right.
And
right.
Those are just some tips, but it's a beautiful question. It's the right question. Thank you.
Cool. Well, other than Brian, we seem to have answered everybody else's questions, or they're just agog at the quantity of wisdom poured out here.
or no one's there.
Oh no, they're there,
Right,
and most of them stayed late. We only lost a few people at the 30-minute mark, but I do want to wind this down. So to all who came, hope you enjoyed this free webinar from RBCS. We do these as a service to the software testing community, because at RBCS we are a not just for profit company. So if you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. Happy to provide a quote for any such help you need. Our coordinates are shown on the screen here. If you're looking for information about a specific thing, a quote, for example, the email info@rbcs-us.com is the place to go. So Rob, once again, thank you very much for your time, and look forward to seeing you in person someday soon when we all get poked in the arm once or twice.
We'll have to pick up our projects and get together again soon. Yep. Thank you, and thank you, everybody, and stay healthy.
Yes, avoid the COVID. Thanks, everybody.
All right.
Bye.
Ciao.